Alright guys, so this is 1.1.4 for Algebra 2. So we're going to be talking about intersections one more time, and we're going to be starting off by taking a look at this problem. So this is going to be a very calculator-focused lesson. If you have your own TI-84 or TI-83 or something in the kind of TI graphing calculator family, you can kind of try and follow along as you can. Otherwise, just kind of watch me do it. When you are in class, you'll be able to have access to that more, and I do want you to be able to kind of use these as best as you can. So to start off, we're going to try and take a look at here's F and here's G. We're going to try and find the intersections of those as many ways as we can. So we could do it by graphing and then calculating the intersection. We could do it by tracing and kind of estimating. You can do it by just kind of looking at it. Then we can also use a table to do that, and then we can also do it algebraically. So those are the kind of methods which we can do. I'm going to kind of go over all of those. So to start off, I'm going to change over to my calculator here. So on this one, I'm going to go ahead and go y is equal to clear out all the stuff that's already in here. And then we're going to do our first one is 2x squared minus 5x plus 6. And then our second equation is negative 2x squared minus x plus 30. Make sure that you have your negative and your minus are different symbols. TIs are kind of picky about that kind of thing, so just kind of watch that. So if I then graph it on the standard window, I see one graph there, and then I see another part of the graph there. So I can see one intersection kind of right there, so that's nice, but there's going to be another one, right? This blue graph is going to keep on going up, and this red graph is going to hit it up there at some point, kind of up higher. So I definitely need to change my zoom to kind of help see that. So if I go to window, I can make my Y max, let's try it at like 50, see if we can then see it at that point. There's a blue graph, and here's the red graph. Boom, now we can fairly easily see both of those. Now I could try and tweak my window to get it more perfect if you want. Z-box, the first option, is a really nice way to kind of zoom in on just the parts you care about. So I'm going to go like here, hit enter, and I'll draw my box to kind of cover all the parts that I want. And then you can get just a nicer way of showing me that exact same thing. You want to be fairly zoomed in, because otherwise, especially things like trace will be really inaccurate. Now I can just kind of move my cursor to kind of guesstimate where about this point is, but again, probably not super accurate there. I'm seeing like 2.99 and 9.1. If I know that these are going to be whole numbers, it's probably going to be 3 and 9 just because of rounding. I can use the trace feature, which is just this button here, and then it'll follow one of those lines. I can get it kind of close there as well. But the problem is it's going to be measuring or going off of each pixel over. So I'm never going to get some nice perfect, hey, it's exactly this, just doing that. But I can get a pretty darn good estimate pretty fast. Now the calculate way, the second feature on this is second calculate. And then we can go down to intersect, because we're looking for an intersection. And we'll ask us 3 questions. It'll say first curve, which is going to default to the blue one, which is here it's Y1. It's also blue because it's the blue curve. Just hit enter. Say second curve, and it'll default to Y2, which is the red one. Hit enter on that. If you only ever have 2 lines in there, just hit enter twice, because it's going to ask you those same 2 things, and it's fine. And then it says guess, because it needs to know, hey, about where are you looking? Because are you looking for this one, or some other one, right? So I'll hit enter there, and it'll actually find the exact calculation of that point, and that is the 0.39. Now I can do that exact same thing, calculate the intersection of the other one. I typically just move my cursor over to it first, and then I hit enter just 3 times in a row, because it says first curve, second curve, and then guess. So as long as you're close, you can just hit enter 3 times and you're done. 1, 2, 3, and then there it is at negative 2.39. 24. Make sure you actually hit that enter 3 times, otherwise you're just using the same thing as a trace feature. So make sure you do that. Now we can also do this with a table, which is the kind of last part that I kind of ask you to do there. So if I hit second TBL set is table set, I'm going to first start it just by table start is where you want to kind of start guessing, and I'm going to say we're going to do 0, and I'm going to be delta table. That little triangle means delta is the change. So how often do you want it to make a measurement on your table? Let's just start it at 1. So we're going to then go second table is right above graph, and here's my table, right? So I can look through this and see, well, here's where my blue line is, here's where my red line is, and I'm looking for when I get the exact same value out of them. See, well, right here at 3, they're both 9, so the 0.39 works for both the blue line and the red line. Can I focus this better? Yeah, it's a little bit hard to see, but hopefully that's not terrible for you. And then if I go down to, where's the one? Well, it's back here, isn't it? There's -2 and 24s. So I got my other point there, right? So you can find the intersections here as well. The only downside is if they're decimals, it's harder to see when you're just kind of counting by whole things here. You can also go to your table set and have it count by like 0.5. And then on my table, it'll go -5, -4.5, -4, -3, 3.5. So that's kind of my 0.5s. But if you're like really off on that, your table's not great at finding things that aren't nice, pretty whole numbers. Right? So there's our kind of calculator methods on doing that. I want to hop back over to this, and then we're going to go over to the next one. So with this one here, so they're working on the intersection of 2x squared minus 5x plus 6, -2x squared minus x plus 30, and hey, we could look at the graphs of these functions. So using your graphing calculator, can you try and solve that by graphing them? So we just kind of did that in a sense. So we can view the window. If I go back to the graph, let me actually pull this back up. I can kind of look at it and just kind of go, oh, that's about 3.9 if you want to count it, or you can do the calculation mode. I already kind of covered the tracing stuff, so we already kind of did most of that. Sorry, I got ahead of myself. But then I want to take a look at this one I wanted. Okay, so we've done the table set stuff to find the table. Number 44 is where we're going to actually get into something new. Okay, so what if we had another way, right? What if we couldn't use our calculator to do these? So that's going to be us doing it by hand algebraically. Now I'm going to go ahead and do that for us. Let me just go ahead and pull out there we go. Okay. And just do it here. So my equations are f of x is 2x squared minus 5x plus 6, and then my g of x is -2x squared minus x plus 30. So we can kind of think of f and g as being y's in a sense, so we can actually do some substitution here. And this is probably the easier way, is just I'm going to plug all of this in for the f here. So I get one big equation of 2x squared minus 5x plus 6 equals -2x squared minus x plus 30. So I'm trying to solve this for x. I'm going to use black just so it shows up a little bit better than maybe that purple is. So I want to get all my x's on one side, all my non-x's on the other side. So if I move this -2x over, I'm going to add 2x squared to both sides. So I'm going to get 4x squared over here, and then I'm going to move over this negative by adding x. So I'm going to get minus 4x. And then I can move this 6 over, or I can leave it. I'm actually going to leave it over on the side because I'm probably going to need to factor this. So if I subtract 30, I'm going to get a -24. and then I'm going to have 0 left over on that side there. So I have a quadratic. I definitely want to solve this by factoring. But first, I'm seeing that I have 4, 4, and 24. I can just either pull out A4 and then divide it off, or just off the bat divide everything by 4. It's kind of like reducing at this point. And I'm going to have x squared minus x minus 6 equals 0. Now this makes it a lot easier for us to factor. You can typically factor these with the kind of shortcut method versus doing, if there's a term in front, you want to do that full box method on it. So I'm looking for, hey, what's going to multiply and give me a negative 6, add and give me a negative 1. So to multiply and get negative 6, add and get negative 1, I need a negative 3 and a positive 2. Let's double check and make sure that, yes, this works. This times this is this times this is negative 3, this times this is positive 2. That's adding me a negative 1. This time this is negative 6. And we're good, so we are factored. So then when I solve it out, I get x equals 3 and x equals negative 2 because of the zero product property on those two things there. So probably a lot of people just stop here and say, hey, my answers are x is 3 and negative 2. Well, that's not your answer because your answers are points, right? You need the y parts that go with these. So I can take these and I can plug them back in up here. And I can say, or over here, I can say the y is equal to, and you can use either one of these, so pick one that's going to be a little bit easier. I'm going to go with probably the top one, just because it's smaller numbers than 30, but not a huge deal. They both work just fine. So 2 times 3 squared minus 5 times 3 plus 6. So that would be 3 squared is 9. 9 times 2 is 18. Minus 15 plus 6. So 18 minus 15 is 3, plus 6 is 9. So then when x is 3, y is 9, so that is the point 3, 9. And make sure you leave these as points. Now my other one would be y is equal to negative 2 in there, so that's going to be 2 times negative 2 squared minus 5 times negative 2 plus 6. Well, negative 2 squared is 4. 4 times 2 is 8. Negative 5 times negative 2 is a positive 10. And then plus 6. Well, 8 and 10 is 18. Plus 6 is 24. So then the other one, the point is negative 2 of the x gives me a y of 24. And those would be those points algebraically. Now, I do want you to be able to, and I will expect you and test you on your ability to do this algebraically as well as on a graph. Graphing is super easy and fast, but being able to do it by hand is good practice on skills that are going to be very, very important for us in the future, and I want to make sure that you do have the ability to do that kind of stuff. So with that, let's take a look at our notes real quick. So we've kind of gone over these things here. Again, you can read through this on how we can solve quadratics. We can do it by factoring and then using the zero product property. That's kind of the more common do it by hand method. That is also the fastest method if you are fairly good at factoring and it factors easily. The downside of solving by factoring is not everything factors, right? You can get ones that just give you ugly decimals or like radicals and fractions and you just can't factor it, right? So that's the downside of it, but if you look at it and you can factor it really quickly, do it. It's always the fastest option to solve things out. If you can't, that's when we want the quadratic formula. Now this is a formula you should have used quite a bit. It's right here. If you don't have it yet, negative b plus or minus the big square root of b squared minus 4ac all over 2a. You can use that, plug in your a, b, and c values, and then you effectively will get your answers out of it like that. So again, you should know most of that stuff there. Read through it. Stuff you don't, put it in your notes, but if you already know it, you're already good. Closure. thinking about the different methods we use to solve. So we covered solving it by graphing and then using the trace or the calculate feature. We solved it by using a table, and then we also solved it algebraically. So all of those have their different uses and different strengths and weaknesses, but those were the methods which we kind of used here today. With that, here is our homework. We're going to do problems 46 through 52. I will talk to you guys next time.